Welcome to the homework solution tutorial. This is on 1.E. I'm covering number 5, 6, 7, and 8. To do this, it asks us for each question below, write the coordinate of the vertex and list the transformation from each of the graph. Then sketch it. Making our life easier, we have our vertex form here, and our vertex form does give us something very useful. Our vertex form does automatically give us our vertex. The vertex, if it's in vertex form, is defined by just h, comma, k. All right, so let's just get that from this one. So it looks like our h here comes here, which is just 6, not -6, it's just 6. Our k here, we don't see it, but there's a plus 0. Our k equals to 0. So in vertex form, the vertex itself would be comma 6, parentheses 6, comma 0. Next, we want to describe the transformation. So here, we also want to know what a is. So a is equal to 1, and it is positive. So that never changed, so we don't need that. So all we need to understand is what does h equals to 6 means. Okay, so a was positive, so a is positive, so we would like to say it opens upwards. Okay, and let me give you reference. There you go. Then their h is equal to 6. That means that is a positive 6, so that is move right 6. So right 6 units. And there you go. To sketch it, okay, so it originally started here at 0, 0. Okay, then it moved to right 6. So 1, 2, 3, 4, 5, 6. So this is where the next point is. There was no movement. Okay, so this is the original one. Okay, it looks like this. Okay, up 1, across 2. Hold on. Give me a second here. Okay, so, and 2, no, sorry. If I plug in 2 here, it would be a 4. Yeah. So this is not right. 2, 1, 2, 3, 4. It should be up here. Okay. So this is how it's supposed to look like. All right. Okay. But it moved to the right. So now it goes 1, 2, 3, 4, 5, 6. There you go. So this is your vertex of 6, comma 0. All right. And remember our next points were these. This was -1, 1, and 1, 1. Now it's moved to be here and here. Then the next point was 2, 4, 2, 4, and the other one was -2, 4. That also was moved. So so it was 1, 2, 3, 4. Sorry, up 3, across 1, up 3, across 1, up 3, across 1. So there you go. That's how you would graph it. All right. There you go. Good. Okay, so these original points, how I'm getting the original points, if you're just wondering, is remember the original function of x squared, right? If you remember your list, your tables, okay? At -2, if you plug in -2 here, it becomes 4. If you plug in -1, it becomes 1. Plug in a 0, 0. Plug in a 1, it's 1. Plug in a 2, it's 4. Okay, this is the original points. All right, so you could always use this if you would like. All right, let's do 6. Okay, all right, now we have to put this into vertex form. If you don't see it, let me help you out. Okay. It looks like negative parentheses x plus 0 squared plus 8. That's how that looked like in vertex form. Okay. So your A here would be a negative. Your H here is 0. And your K here is 8. So this does now give, we could also get the vertex. The vertex should be 0, comma 8. And that would be the vertex, right? Because that's your H and your K. So let's just write that here. And let's do the transformation. Because it is a negative, it does open downwards. Is there a stretch? No, the A is still 1. H equals to 0. Nothing happens left or right. But K is a positive 8. So we can say K is 8. So this is up 8 units. All right. So again, our original points, 0, 0, 1, 1, negative 1, 1, 2, 1, 2, 3, 4, and 2, 4. Okay, those were our original points. Now, it moved up. Okay, so it goes 1, 2, 3, 4, 5, 6, 7, 8. Now remember, it opens downwards, so it doesn't go up like this. Okay, it goes down, so it would look like that. Okay, and then it goes 1, 2, 3 across 1, 1, 2, 3 across 1. So it would look something like this. All right. And if you are using a table of values for it, okay, and if you want to plug it in here, you could generate your table of values to get the points. All right. And then same process here. Let's do it. A equals to 2. Your H here is 1. Your K here equals to 0. Your vertex is going to be that point of 1, comma 0. Your transformation, so it is a value 2. Okay, and we know that what does 2 mean? It's a vertical compression. All right. Okay, so it's a vertical compression. So it opens. It opens up. Okay, upwards. It compress vertically by a factor of 2, and then the H is 1, so that is right 1, and there is right 1 unit, and there's no K value. All right, so our original is 0, 0, but we move to the right one. Okay, now take a look. Do you see how it's a vertical compression of this 2? So 2 is being multiplied into all those values. So if you plug in a 1 here, just do it. Just plug in a 1. Okay. If you plug in a 1 here, it does that. Then let's plug in a 2. Okay. So if I plug in a 2, look, 2 minus 1 squared. Okay. 2 minus 1 is 1 squared. 2 times 1 is 2. Okay. So that is 1 is 2. And again, it's symmetrical. Now if you're gonna, so this is if I plug in a 2. Yeah, if I plug in a 2. Let's plug in a 1, 2. Let's plug in a 3 here. Okay. 3 minus 1 is 2 squared. 2 squared is a 4. This becomes an 8. So at the it's if I plug in a 3, you get an 8. So this is 3 1, 2, 3, 4, 5, 6, 7, 8. And it is symmetrical. So there you go. Do you see that? Whoop. See? It compresses. It got skinnier. Okay, that's what I mean by compress. Okay, that's what I mean by compress. Okay, the original was a little bit fatter. Okay. Now, what happens when it's a negative 1/2 that is out in front? Well, let's just do it. A is negative 1/2, so this is negative. Okay, and it's gonna be a stretch here. Okay, it's gonna get fatter, wider. The H is going to be a -5 again, because remember, it's written as x minus -5 squared, because remember it's a plus here, so make sure in vertex form it's x minus that. Okay, and there's no k value here, so it's 0, so the k here is just a 0. All right, so we can get our vertex form. It looks like it's -5, 0. And we know that A is negative, so this is open downward. H equals to -5. Also it's the absolute value of A is 1/2, so that is a vertical stretch. Okay, it's a vertical stretch. All right, and your H is a vertical stretch, and then H is -5, so H equals to -5, so this is left 5 units. All right, let's do it. So our original was 0, 0, but now it went 5 units to the left. So 1, 2, 3, 4, 5. Now it opens downwards. Okay, so technically it would be here and here, right? But no, there is a stretch. Okay, let's see it. All right, so the next point here is 1, 2, -1, -2, -3, -4. So this is -4. Okay, so this is what I'm going to do. I'm going to plug in -4 here into the function. Okay, so you can see it. All right, -4 plus 5 squared. Okay, so because that's the original function. So -1/2 parentheses -4 plus 5, that's a 1 squared. And this just looks like it's a 1, yeah, -1/2. Okay. Let me see here. All right, so you see here, I plugged in the 2 points next to it. So when it's right here, it looks like that is the point -4, comma, -1/2. And next to it, it would be -6, comma, -1/2. Do you see that? Okay. It's hard to see, so what I'm going to do is I'm going to grab a couple more points, okay? So I'm going to erase this and see what happens when I plug in, let's see, one more next to it. So I think this is -3 and -7. So let me do that math here for you. There you go. I did the algebra for you. So it looks like when it's -3, that point is -2. So it's 1, 2. Looks like right there. And the other one is -7 is at -2 here. Right? So notice it got wider. Okay. All right. It got wider. It got fatter because it is a vertical stretch. So do you see how it got stretched outwards? That's what I mean by vertically stretch. Okay, so if you're a little bit confused, again, refer to the core concept here about the vertical compression and the vertical stretch. And again, the strategy that I use is that if you want to do this numerically and want to make sure you find the points, get the vertex grab the x values and plug it in that are next to it, and you can find the values. Okay, there you go.